All right, again, good morning. Good morning. While we're waiting for everybody to come in, take a look. If you haven't looked at the vocabulary, you should. So go back a page, look at the vocabulary, and in particular, uh, look over this box, being able to tell the difference between human remains and non-human remains. Also, your Casey Anthony case study was due yesterday, so make sure that you've submitted that. Okay. All right, Abigail, I'll check on that in a minute. All righty. I'll give folks another minute to get logged in and then we'll go ahead and get started. Again, if you've just logged in, let me wait till I let this person in before I say this. All right, if you've just logged in, we're in Canvas on human and non-human remains lesson. All right, I'm going to stop sharing for a minute to do the attendance and to get the Go Guardian started. All right, just a reminder, I try to do the attendance 5 minutes into class. So after that, you're going to be marked late. Uh, Again, for those who I just let in, we're looking at the Canvas page on, wait a minute, got 3 more people. Okay, let's see. Hit that. Okay. Give me another. All right, so again, give me 1 minute to get this attendance checked off, and then we'll do the Nearpod on human remains. But in the meantime, make sure you familiarizing yourself with the vocabulary and the initial reading on that human remains or non-human remains page. Okay. All right, I just put the Nearpod link in the chat, so if everybody would log into that, we'll go ahead and get started working on that. All right, get 1 second. All right, so I need everybody to log in. Because remember, it lets me know when 100% of when I have 100% participation. So please make sure you're logged in. The Nearpod link is in the chat. She looks fierce. All right. Okay. Go ahead and answer this question. because you should have read on that page. So everybody go ahead and I'm going to switch this. Let's see how many everybody logged in. All right, everybody should have an answer. I'll check back in a minute. All right, got one in the waiting room. All right, Xavier, I just put the Nearpod link in the chat. Please log in as soon as possible. All right, hopefully everybody's had a minute to answer the question. So let's look at what you got to say. Say a little bit. You should look at their bone structure. Okay. Everybody was supposed to have an answer. Let's go. Let's go. Give you another minute. Remember, it gives me a transcript of everything that. So participation, participation, participation. All right. Humans different structure. Okay, I like that, Deja. It's a good thing. Did it? Okay, Addison, that's a good answer. Where this one there? All right, Anika, thank you. Fingerprints are important. Okay. DNA testing. Okay. Okay. All right, well, we're going to go on. But like I said, it's still going to tell me that you didn't make a comment. You're supposed to participate. Participate, participate, participate. So I got a couple of no answers. Shouldn't have any no answers. Xavier just got here and he's already answered the question. All right, let's go. Remember, pay attention. And I fixed the sound issue, so you should be able to hear it better.
My name is Professor Sue Black. I'm Director of the Centre for Anatomy and Human Identification at the University of Dundee, and I'm also the Deputy Principal for Public Engagement. At the moment, we're sitting in the dissecting room within the university, and about 70 to 80 bodies are bequeathed to us in the anatomy department every year that come here for dissection. And we train forensic
I'm going to
anthropologists.
pause that right there. Do you know what she means by that? I got somebody else to let in. What does she mean by they've been bequeathed to them? Do you know how all those bodies end up there? What is, somebody type in the chat, what does it mean they donations? Thank you, Alyssa. They've been donated. So people leave it in their will that they want to lend their bodies to science at the end. So that's where they get those bodies from. Your Wi-Fi isn't the greatest. Okay, gotcha. Now I'll keep a lookout to make sure I let you back in.
As well as other forensic experts. And it's really important for a forensic anthropologist that they don't just understand the bones, they have to understand the soft tissue, because that's a really important and credible part of that identification process. So their training starts in here, in the dissection of the human body. Bones are really important, bones and teeth, because they survive, and that makes them of particular importance when we have an individual that we don't know who they are. If we can take DNA of a body, if we can take fingerprints of a body, we've got a good chance of identifying them. But if the body's decomposed or it's skeletal, the amount of information is obviously diminished. So our responsibility is to take that bone, and it may only be a part of a bone, it might not be a whole skeleton, and try to determine something about the identity of the individual. And there are four.
All right, everybody needs to answer the question. I got one more person in the waiting room. Can I turn on the captions? Okay. Closed captions are turned on. All right. Who did I just let in? Kinsey. All right, give me 1 second to make sure Kinsey has the log in. All right, Kinsey, we're in the Nearpod. I just sent you the login for the Nearpod. We're recording participation, so everybody needs to answer. All right, so let's look, see how you've done. Okay. Okay. All righty. It says, which of the following physical characteristics can be approximately determined by the victim's teeth and bones? All right, so everybody's now that now that you see the everybody else's answers, everybody's changing their answers, but that's okay. That's okay. So wait, height can be approximately determined by teeth and bones. Okay, got us. Got somebody still holding on to weight. So the correct answer is height. All righty, and just a little heads up. Usually, just before these questions come up, it's probably the last thing they said. So just be listening. Uh-oh, hold on. I can't hear, so I don't know. Okay, the volume is up there. I don't know what happened to the volume. Let me go back just a little bit.
And there are 4 primary identifiers that we can all relate to. So you have a sex, you're either male or female, but there is a grey area within that as well. You have an age at which you go missing or an age at which you die. You have an ethnic origin. Now that doesn't mean where you're born, that means about your ethnic history. So where did your ancestors come from? And you have a height. So that when you hear the police on the television, for example, describing a suspect, they'll say he's a male, age between 25 and 30, 5'6" to 5'8" in height and white.
I'm going to pause it there for you to write those down. 4 primary identifiers. And I'll probably pause it along the way for you to take random notes other than the questions that they're asking. But you should write down that there are 4 primary identifiers: sex, age, ethnic origin, and height. Okay.
And those are the basic biological identifiers. It's the first thing that we start to look at when we have a skeleton in front of us. But you can imagine that there are thousands, if not tens of thousands of individuals that could fit into the one profile. So our next job is to say, what's different about this person? What can we see within them that would allow somebody who's listening to Crime Watch or whatever the program may be that goes, oh, my father had that, my brother had that, my mother had that. It's about saying, what kind of pathological condition do they have? Had they broken a bone many years ago? Do they have dental work? Is there any evidence of surgery? Would they have walked with a limp? Did they have an abnormality of a finger? All of those things that are the anatomical individualities, if you like, of each person. It's our job to try and extract as many of those as possible from the skeleton. And that's the really difficult part. DVI stands for Disaster Victim Identification. And it's where we have...
Pause that so you can write that down. Come back just a little bit. Oh, wait a sec. Okay, that'll do that again.
Is this human? Is this animal? If you think of the World Trade Center, they had restaurants. In plane crash, their job on the ground will be to identify these small parts, these fragments. Are they human? Are they not human? Which part of the human may they be, and they will get bagged up and then sent to the mortuary. You might have an anthropologist at the triage part of the
I
mortuary
think that,
in
hold on, I
Ukraine
think
that are the anatomical
okay.
individualities, if you like, of each person. It's our job to try and extract as many of those as possible from the skeleton, and that's the really difficult part.
Okay.
DVI stands for Disaster Victim Identification.
Okay, write that down. I was trying to get it to stop. DVI. What is DVI? And unfortunately, this is something that they're having to do now with this Helene hurricane, because there was a lot of disaster in many places. I think Georgia got hit very badly, as well as North Carolina and some other places.
Disaster victim identification, and it's where we have mass fatalities, for example. So if you were to think about the plane crash in Ukraine very recently, that's the kind of situation when a forensic DVI team would go in. Forensic anthropologists can be involved in a number of places, so they may be involved at the scene of the incident, particularly if the bodies are burnt or if there's explosions, so that in the London bombings and again in the Ukraine plane crash, their job on the ground will be to identify these small parts, these fragments. Are they human? Are they not human? Which part of the human may they be? And they will get bagged up and then sent to the mortuary. You might have an anthropologist at the triage part of the mortuary, because when these bags come in, it will be opening them up again to say, is this human? Is this animal? If you think of the World Trade Center, they had restaurants, so there'd be bits of pig, there'd be bits of sheep. We need to separate those out. And also from the anatomical perspective, we'll be able to say in fragmented material, this is the top part of a left thigh, this is the bottom part of a right forearm, and it allows you to start putting the jigsaw perhaps together, the human jigsaw back together, if you have fragmented or exploded remains. And then the anthropologist is also in the mortuary, in the station associated with identification. So when the body or the body part is coming through, is it male or female? Is it a young individual? Is it an elderly individual? What's the
Okay, so let's go ahead and answer this question. I'm going to take my view off for a minute. Oops. And let you think about that. Remember, everybody needs to participate. All right, so let's look at how you doing. Okay, so 80% of you said it's true. 5% of you still not answering. Why everybody's supposed to answer? All right, so yes, it is true. Yes, it is true. You can identify, so that might be a note you need to write down. A victim's approximate age can be deduced by teeth and bone, teeth or bones. Oops.
individual? What's the ethnic origin of this person? How tall are they? What sort of other indicators of their identity are present? Do we have previous fractures? Do we have these disease processes? And so the anthropologist is in a multiple number of the places within the scene, if you like. There's no doubt that what we're exposed to is traumatic. You don't see the best side of life, and as a parent you become rather more protective perhaps than most, because you see the volume of child abuse, child pornography, you see murders, you see mass fatality events. All of these are obviously going to influence the way in which you lead your own life. And for me, my desensitization or sensitization, depending which way you look at it, really came about very gradually. So part of my job as a teenager was working in a butcher shop. So I was used to dealing with bone and muscle and blood and viscera, and it didn't upset me in any way.
Okay. All right, desensitized to this means making it easier for you to be able to deal with working with it. Not everybody's cut out to work in this area. So, true or false, you should ideally be desensitized to the sight of bones, muscles, blood, and viscera to be able to work effectively in a dissecting room. And I think everybody's going to agree that that's true. That's true. And again, folks, we got too many of y'all not answering the question. Stay with us so you don't have to think. And don't wait for me to show the answer. This was a true false question. All right, so yes, this is not a job for everybody. Even in a biology class, sometimes y'all not cut out.
Moving into a
for
dissecting room was, if you like, the next stage of that. But it does take quite a lot of courage to make that first cut in human skin. But once you do, and you're inside the human body, it is just such an amazing world that you marvel in it. You're not repelled by it. So the first time you see your forensic case where that body, that beautiful body, is disrupted, whether it's disrupted by fire, by decomposition, by trauma, whatever it may be, you almost look beyond that to what it was, and you compare the two. And in comparison of the two, it allows you to determine what happened. What happened between that perfect intact body, you know what it should look like, and what you have in front of you. So it becomes the investigation, it becomes the puzzle, and we all love puzzles. Kosovo was unquestionably a turning point in my career. I got the phone call that said, "What are you doing on Saturday?" And I made the mistake of saying nothing. And Peter Vanessis, who was the forensic pathologist, said, "We need you out here." I didn't know what I was going out to, hadn't got a clue. And it was really quite scary, but you don't think about these things. You just get on the plane and you think, I'll figure it out when I get to the other end. It was incredibly traumatic, I do have to say, but also incredibly rewarding, because you really got to feel part of an integral team. You were really working at the junction to help the local communities address the necessary judicial aspects of what went on, and to help the world recognise what had occurred in that country. Probably the one that made the most impact on me was a family, and it was a family who came out of the villages to go up into the countryside, and they would come back into the town for provisions. And on a particular day, Dad was driving the tractor, whole family was on the trailer behind him, and an RPG, rocket propelled grenade, took out the trailer. The father who was driving the tractor was sniped in the leg, so he was shot and he managed to crawl away into the undergrowth. But everybody who was sitting on the back of that trailer died, and that included his wife, his wife's sister, their mother, and their 6 children. And so when we came back almost a year later to exhume the bodies that he had buried, so if you imagine, under cover of darkness, having been sniped in the leg, he still went around and found what was left of the parts of his family and buried them, because he knew if he didn't, the dogs would get them. And it's a tremendous foresight, it's a tremendous strength, I think, to be able to do that. So we come along and say, we want to exhume the bodies of your family because this is important for indictment against Milosevic. And when we dug the hole that he'd created, we found enough to fill 2 body bags. So all those people, not enough to fill 2 body bags. And we went back to the mortuary and we set out 11 pieces of fabric to say, we're going to put something of each person into each of these, and we know we're going to have an area that we can't separate. And part of my expertise that I developed, because we'd written the book on it, was the identification of children. And so it was one of those things about feeling you were in the right place at the right time. So I was able to identify a bit of each of the children. Now, it'd be very tempting to put just a bit in each and no one would know. You can't do that, because morally and ethically that's completely wrong. But in addition to that, the courts are going to say, right, we're going to exhume that bag. And if what's in that bag is not what's in your report, you're not a credible witness, and we're not going to take any evidence you've given. So it's extremely important that you uphold the standards of forensic practice, regardless of where you are in the world. So I had bits of every part of every individual. My problem was that there was 2 14-year-old twin boys. and how you separate two twin boys. You can't do it through DNA because we haven't got any matching. There's no fingerprints. All we had of the twin 14-year-old boys was the top part of their arms, but one of them had a Mickey Mouse vest associated with it. And I said to the police officers, go and ask Dad which of his children had a Mickey Mouse vest. Don't say which of the boys, which of the twins, which of the children. And if he comes back with a name, and that name is one of the twin boys, we've got something.
All right. Take a minute to answer that question. Everybody, please take a minute to answer the question. And it says, in your own words, how are pieces of clothing or accessories attached to partial cadavers can be used to identify the victims? And you can use the one that she just mentioned. All right, let's see how you're doing. All right, they can be used to identify the victim's gender and age. I guess because certain clothing will be typically worn by girls, typically worn by boys. All right, accessories attached to cadavers, asking family. Yes, that's good. Thank you. The ones particularly. All right. Jacoby, why I got no answer for you. All right, because people were there. Okay, that's good. Anika, what's happening? No answer. Sorry, not Anika, Akia. Just give you a whole new name. And Neve, that's a good answer, except she said, like in cases like this, these children don't have any record of their DNA. So unless they've done something, had dental work or some type of hospital work, they wouldn't be able to compare the sample to a DNA. That's what she was saying. It's hard. They don't have fingerprints. Nobody's ever fingerprinted them because they're young children. But so that might not be as helpful. Xavier White, I have no answer. All righty. Got a couple of other people. Got a couple of other people no answer, but we're gonna go on. Thank you. All right.
And that's exactly what happened. So he came back and he said, oh, my son was absolutely mad about Mickey Mouse. That was his pride and joy. That would be that boy. And so just something as simple as a piece of clothing that was so important to the child led us to being able to give that man back body bags for each and every member of his family, plus an element that we couldn't separate. And for us to be able to, to even imagine what he went through, and for his quietness, for his dignity, for his sheer courage, it was the most humbling experience that any of us had come across within Kosovo. And if there was any reason why I was there, it was to help that man get some element of closure, given the enormity of what he'd been through. He felt that whilst they were all in one grave and one hole in the ground, God would not be able to find them. God could only find them if they were each in their own grave with their own name on that gravestone. So if we helped him in any way, then everything we did in those 2 years was worth it for that.
Okay. Go ahead and answer that question. Because we're just at the beginning of the course. So this would be important for everybody to answer so we know, have some direction as to where to go. Do you think you could do this job? Or is this not the area of forensics that you would want to work in? Give another minute for everybody to answer. I really would like a response from everybody from this question. Okay. Still got a couple of people no answer. Thank you. Caitlin, Bria, Isaiah. Okay, Bria, I got yours. Alyssa. All right, right now it's just Caitlin and Isaiah and Alyssa. Need an answer. Okay, so let's come back to our Canvas unit. All right, so hopefully you've had a minute to look at this chart. So gross skeletal anatomy, it says forensics examines bones in 3 levels. So make a note of that. 3 levels. Gross skeletal anatomy, bone macrostructure. So gross skeletal anatomy is the whole skeleton. Can we put the whole body back together? Then there are large pieces, and then microstructures would be bone fragments. Okay. All right. So then it goes to describe what gross. All of those are the large pieces that you would find. So like the skull, the jawbone, and the skull is divided into a couple of other pieces. So make sure that you've looked through all of that. So they can tell the difference between a human bone structure and non-human bone structure by size and shape. I'm sure when you did biology, they talked about teeth structure. You could tell what kind of food an organism eats by the kind of teeth they have. So we have teeth that are designed for, you know, eating certain types of food, but if you were a carnivore, you would have stronger, sharper teeth because you're always tearing at meat. Herbivores have flat because they grind um, the grains that they eat, so their structure is different. And then you have the upper limbs where bones and muscles are attached, so they're shaped differently. So make sure you've read those boxes over. All right, so let's take a look at this. All right, everybody take a few minutes to go through this game. Bones are easily identified between species while others are more subtle differences. Can you determine which type of animal that these go with? All right, so take a minute, like it says, hover over. So before you hover, take a guess. Some of them are quite obvious. All right, this one is important. The centaur, and we have to be in as if you're watching all these mythical movies and things these days, so the centaurs are quite popular in these movies. And I watched the Percy Jackson one, and they have centaurs. Uh, But notice it says you can easily tell if its skeletons have been manipulated to represent something that is not. Okay. All right. So then you had this one. All right. This is important because they like to keep comparing us to monkeys. So there is a difference. They're not the same. That one is interesting. Okay. The difference between human and non-human bones is mostly due to the way the human and others walk or move. So that's important because the way you walk or move, for example, let me go back up here. Look at the way this juvenile gorilla is crouched. That's different. Look at the way this s- uh, st- speculative owl is perched. So the way they walk or move is definitely descriptive in their bone structures. Okay. So you can tell whether they're bipedal, and that means you have 2 feet, you walk on 2 feet, 2 legs. So their upper limbs are not proportional. Okay. They're not the same. Not like a dog or a cat where all four would be about the same because they, that's how they walk. Whereas we have longer legs and not so long the arms are not as long as the legs. All right. Well, some bones are noticeably different. Some are similar. And I'm summarizing because hopefully you have read this for yourself. Many infant bones may look similar to other small animals, bones such as a raccoon paw, for example, and they've got these paws, hands down here, have similarities. Okay. But still, again, you can tell while they may have 5 digits, uh, they're longer because they grab things differently than we do. All right. Macrostructure refers to the structure of an individual bones that can be seen without magnification. That's kind of odd. So anytime you see macro, that means large. Anytime you see micro, that means you have to examine that under the microscope. So actually looking at bone cells and tissue cells, those have to be looked at under the microscope. All right, let's look at this. Other considerations. Many bone bodies are represented by the remains. Check the duplicates of the same bone, such as 2 left femurs. Evaluate the size and condition of the bones. Um, if the multiple sets of bones are identified, they are from the same time period. So your objective in this is to tell the difference. All right. How old are the remains? Okay, so again, in this one, you associate it by events that might be buried with them, and then so you know something about the culture. This is how they do the remains that they find in the pyramids. Things are buried with them, so they are able to identify the remains by the culture. All right, we got time to go forward. All right, so let's look at this one. Skin coloration. So if you hadn't had a chance to read this over, take about 5 minutes to read that over, and then we'll look at this one down here. All right. And while you're doing that, I need to. That's all right. Got a couple of people who've been idle for quite a while. Folks, when I check back on GoGuardian, it's telling me you've been idle for 15 minutes. I'm either gonna mark you absent or you're tardy, but you gotta be present and functioning. Not just at your computer on and it's sitting there. Somebody absent and they all of a sudden appeared. Okay. All right, so we've got some vocabulary words here. Actually, let me come back up here. Okay. All right, gotcha. I forgot you had told me about that, so let me quickly fix that. Okay, gotcha. Gotcha. All right, so we're looking at what they can tell. So these are the things that what's your skin? So if the skin is still intact, things that they can tell about the victim from their skin. So have they had any viruses or bacteria? Or have their exposure to the sun? Sometimes you have excuse me, liver damage leaves spots. Certain organ damage leaves spots on your skin. Blood loss and water loss. Are your cells all dried up because you're dehydrated? Okay. All right. This is what your skin does for you. So so they can look at, is the body properly insulated? Was there any temperature regulation? They can measure the temperature of the body. Is it, you know, is it responding still to stimulus when so that can do time of death depending on the response of the skin. I don't know if you've ever seen any of these crime shows, because sometimes they can pinch the skin to see test the elasticity of the skin and determine how long um, the body has been dead. All right, so let's look at these. This, so these are vocabulary. You're going to have a little quiz later on vocabulary. All right, livor mortis or death color. So you need to know, if you saw a picture like this, would you be able to identify it by the color of the skin? All right, Tardieu spots, also known as afflix, and I'm not even going to pronounce that properly. Tecti. These are dark purple spots on the skin and some organs. They're caused by capillaries bursting under the skin. So again, some poisons cause your veins and blood vessels to pop. All right, skin turns green due to bacterial flourishing in the body. Marbling, dark colors of veins throughout the skin. And this would help you say how many days the body might have been left. All right, post-mortem skin discoloration. So again, the different colorings that are not supposed to be normal might be showing up due to carbon monoxide poisoning, different cold temperatures, Okay, so make sure you're familiar with all of these types of identifications. So the quiz that you would have would be a matching situation where you're going to match. I don't think this one is published yet. There we go. All right. If it wasn't published for you, it should be published now. All right, so go ahead, take a few minutes to read this page. More vocabulary. Okay, everybody. Oh, wait a second. Let me come out and make sure that it's, because I clicked publish, but it doesn't look like it published. It should be post-mortem changes, rigor mortis, and algor mortis lesson. That's where everybody should be. It should say published. Let me know if it isn't. Let me just go ahead and do all of these. Okay, good.
This is a fizzy tablet and some water. If I put it inside, it starts fizzing. If I put a cap on top of it,
All right, so since we only have a few minutes left, I'm going to share this last video with you. It's the closed caption on.
Imagine that you're watching your favorite crime drama show. A murder has taken place. The police and forensic experts are looking for clues to catch the killer. One of the most important clues to solving the crime is determining when the victim died. The expert looks at the body, checks the body temperature, and examines the body's position. After a thorough examination, The expert then states the approximate time of death. The question is, how does a forensic expert calculate the time of death? The time of death is not the exact time that a person died. It is instead a time frame in which the person could have died based on the evidence presented. Forensic scientists calculate the time of death using many techniques. Their first go-to method is to study the physical changes that happen in the body after death. So what are these signs? There are 4 post-mortem signs that tell a great deal about time of death. These are physical observable changes that occur in the body in the first 24 to 48 hours after the heart stops beating and the nervous system shuts down. The first sign, pallor mortis. As the heart stops beating, the circulation of blood throughout the body decreases. The organs farther away from the heart, like the skin, stop receiving blood. This gives a corpse the pale, lifeless appearance that we associate with death. This paleness, which appears 15 to 30 minutes after death, is called pallor mortis. It is one of the first identifiable signs of death. The second sign, algor mortis. Humans are homeothermic, which means that we maintain a constant internal body temperature. This constant average temperature is maintained by balancing the heat produced in the body with the heat lost. The circulatory system is an important mechanism by which humans maintain an average internal temperature of 37 degrees Celsius. Heat is produced primarily through the various metabolic reactions happening in our body. This produced heat is dissipated from deeper organs, such as the liver and brain, to the outer parts, such as the skin, through the movement of blood. Under the first layer of skin, the epidermis, lies a network of capillaries. These capillaries allow heat produced by the body to be released into the air. Without the heart beating, blood cannot distribute heat and regulate body temperature. This leads to the body temperature reaching equilibrium with the external temperature. If the temperature is less than 37 degrees Celsius outside in the first hour after death, then the temperature of the body will decrease by 2 degrees and then continue to decrease by 1 degree every hour. Algor mortis is not an accurate way to back calculate the time of death, however, as it varies based on external conditions, such as weather, and is affected by whether the corpse was wearing clothes or not. The third sign, rigor mortis. This sign is one of the most important signs when it comes to determining the time of death. Rigor mortis, which literally means stiff death, is the contraction of the muscles in the body after death. Before rigor mortis, all the muscles relax in a step called primary flaccidity. This happens because, after death, brain activity decreases until it completely stops. Without the brain giving muscles a signal to contract, the muscles remain in a relaxed state. Primary flaccidity lasts for 1 to 2 hours after death. The first muscles to relax are those in the eyelids, fingers, and toes. In this stage, the corpse usually releases urine and gas, as muscles controlling urination and passing gas are relaxed. Primary flaccidity is followed by rigor mortis. Muscles stiffen up in rigor mortis because of cells being broken down by digestive enzymes. This cellular breakdown is a normal part of body decomposition and is called autolysis. The breakdown of cells makes holes in the boundary of the cell and its compartments. This releases calcium ions from the separate compartment within the cell where they are stored. This calcium is crucial for initiating contraction. During normal living conditions, a signal from the nervous system triggers the calcium to release from its compartment. Another factor causing rigor mortis is the lack of ATP, the energy-giving molecule in the muscle cells. Once calcium initiates muscle contraction, myosin, a protein molecule that moves things around in the cell, binds to actin, a long chain of proteins that form the skeleton of a cell. Once the myosin binds to actin, it uses the energy from ATP to pull the actin, making the muscle fiber shorter and shorter with each pull. Immediately after death, muscles can still produce ATP. Muscles have reserves of glucose in the form of the polysaccharide glycogen, which it breaks down in the absence of oxygen to provide ATP. This ATP is used up in muscle contraction, but the muscles also need ATP to relax. This means that the actin and myosin will remain contracted until the muscle is completely decomposed. Rigor mortis starts in the same order that primary flaccidity does, with the eyes and fingers, and slowly progresses to the rest of the body. Rigor mortis reaches its peak 12 hours post-mortem. After that, the muscles begin to relax in the same order that they began contraction. After rigor mortis comes a second cycle of relaxation, called secondary flaccidity, which is due to muscle degeneration. Digestive enzymes break down the proteins in the muscles, including the muscle contracting machinery. Forensic experts use this progression of muscle relaxation and stiffening to estimate the time of death. They will check to see which parts of the body have stiffened and make an estimate based on what they find. It is more reliable than algor mortis, as it isn't as affected by external conditions. The fourth sign, livor mortis. After death, blood is subject to the forces of gravity, now that the heart isn't moving it around any longer. It pools wherever the forces of gravity is strongest. This starts about 15 to 30 minutes after death and starts to become visible 2 hours after death. Lividity, as it is called, starts to become fixed after 6 hours as the blood vessels begin to break down. After 8 to 12 hours, a purple coloration develops. This purple color develops because the deoxygenation of hemoglobin forms deoxyhemoglobin, which has a purple-blue color. Livor mortis can be very useful for determining time of death. Once lividity is fixed, it doesn't fade, even when the body is moved. If a part of the body came in contact with a firm surface that obstructs the blood flow, an impression of it will show on the skin that is surrounded by pooled blood. The color or pattern of lividity can allow forensic scientists to guess not only what the time of death could be, but also the cause of death. Lividity in the extremities, such as the fingers, would suggest that the body was upright, as opposed to lividity developed on the back, which would suggest a horizontal position. These 4 signs are commonly used together in order to estimate the time of death. The time of death is not 100% accurate, however, because of so many other factors, such as the environment, weather, clothes, or whether the victim was moved. Forensic experts will most likely give a time frame rather than an exact time. So, the next time you're watching a crime drama, don't forget to be that guy and point out all the loopholes you see.
Alrighty. Okay, so we got about 1 minute. I'm going to make sure that this video is on the playlist. Mr. Phillips is going to help me make sure the playlist is set aside so that you can find things easily. But this will definitely be on there because it just went through all your vocabulary words. So you need to make sure that if you need to see it again, you should see it again. All right, so if you have no questions for me, we're good for today.